just math, y'all. You can do it. It's not that hard. It's just math. Y'all, listen, we got Calculus 1 right here on this channel, and we're going to do some 2-5. This is 2-5 video number 2. We're picking up where we left off last time. Let's see, I think we're right there. We are doing examples. We are finding limits as x goes to infinity. And we are going to do these. We did a few. Basically, we kind of plug infinity in and then use our little rules that we have. And it works pretty good. It's not as hard as some of the other stuff. So these are different. These are some big polynomials. And so we're going to do a little bit of algebra before we jump in and start plugging in. And so when you see these, I'm going to compare to the last ones. Let's look at the last slide. See, now these were just regular polynomials. Okay, except for number 2. But we were able just to real simply just plug those in. So in these problems, we're dealing with these rationals. Go back. Come on. Wake up. There we go. We're dealing with these rational functions. And so we're going to try to do something real quick. We're going to plug in. If we did the plug-in, we would get infinity over infinity. And that's called the indeterminate form. When you get infinity over infinity. And so you don't want to do that. So that when you plugged in, you just got infinity over infinity, and that's not going to work. So here's what we're going to do. We're going to divide each term by the highest power of x. And this is going to simplify out. It's going to see if I give myself enough room to do this. So the highest power of x in the denominator. That's very important. Okay. So in the denominator, our highest power of x is x to the 4th. So I'm going to have 5 over x to the 4th plus 3x over x to the 4th plus 6x to the 4th over x to the 4th over x to the 4th over x to the 4th. Okay, I'm going to simplify this up. The denominator gives me 1. The numerator, I have 5 over x to the 4th plus 3 over x to the 3rd plus 6. And now I'm going to do the limit as x goes to infinity here. Now this is where we can plug them in and get them to go to 0. So now, when I put in the infinity in each place of the x, it doesn't matter about the power of infinity. Doesn't matter at all. This goes to 0. This goes to 0. And I'm left with 6. And that's my answer. The limit goes to 6. All right, we're going to do the next one. Same thing. Divide by the highest power of x in the denominator, which would be x to the 3rd. A little water. Stop my cough. So here we go. 21. I want that pink. 21 x to the 3rd over x to the 3rd. Over. Excuse me. Okay, so I've done all that. Gives me 21 plus 3 over x minus 5 over x squared over 14 plus 1 over x plus 3 over x squared plus 4 over x to the 3rd. I have to get a darker color here. Okay. So every one of these with x in the denominator, when I put infinity in there, it's going to 0. That's going to 0. That's going to 0. That's going to 0. Notice these are not 1. These are going to 0. And that's going to 0. Okay, and so I'm left with this fraction. So the limit as x goes to infinity of f of x is 21 over 14, which of course you all know needs to be reduced to 3 over 2. All right, let's look at some more examples. This last one is similar to one on your homework, and it specifically asks for the horizontal asymptote, and so I'm going to include that in our problem. This time we're going to negative infinity. Okay, we are going to divide by the highest power of x again. Do the same thing. It'll be 3x squared over x. Let me re-emphasize, highest power of x in the denominator. So that's what we're dividing everything by, the highest power of x in the denominator. Okay, so that's going to give me 3x plus 5 over 1 plus 2 over x. And now when I plug in negative infinity, this is going to give me a negative infinity plus 5 on top. That's going to 0 over 1. So the answer to this one is actually going to be just negative infinity. So that one's a little bit different. All right, let's do 7. We're going to do, again, divide by the highest power of x in the denominator, which would be x to the 4th. So 2x to the 3rd over x to the 4th minus 4 over x to the 4th. Plus 7x squared over x to the 4th. All right, that's going to give me 2 over x minus 4 over x to the 4th over 1 plus 7 over x squared. Now, this one's going to 0. The limit of that one is going to be 0. And the limit of that one's going to be 0. So I have 0 minus 0 over 1 plus 0. So my limit is 0. And that is for positive infinity. All right, so for negative infinity, is it going to be different? No, it is not going to be different. It's also going to be 0. Okay, now, the horizontal asymptote. The horizontal asymptote is the line, the horizontal line, y equal 0. And so if you were to graph this thing, you would have a horizontal asymptote on the x-axis, because that's y equals 0. And that's what this one would look like. Okay, it would have a horizontal asymptote there. So each one of these represents the horizontal asymptote rules. If you go back and look them up from your pre-cal, all we did in pre-cal was just compare degrees. If it was big on bottom, that was the horizontal asymptote. Is that going to work? Yeah. If it's big on top, it didn't have a horizontal asymptote. It went off into infinity. If it was the same, you got to look back at those notes from pre-cal. If it was the same, you looked at the leading coefficients, 6 over 1, and that was your horizontal asymptote. If they were the same degrees, you looked at the leading coefficients, and that was your horizontal asymptote. So on these rational functions, this idea of horizontal asymptotes and limits to infinity are very, very, very much the same. And so you can go back to those rules, but we want to understand what happens when that infinity is in the denominator, that it goes to 0. That's just super important. All right, it's just math, y'all. I'm done for today. Tomorrow I'll get your last video of continuity up and your last assignments up. And you can have a great weekend working on